was distributed. And you can do that in your calculator by multiplying -3 by your fraction in alpha y equals. So I'll do that, but you guys can grab your phones. Fraction bar, alpha y equals, you get that, and it'll simplify it for you. Okay. Don't forget your x. Also multiply -3 and -2. Don't forget the negatives. If you need to use a calculator, that's fine. But make sure you're using the negatives for negative numbers. So that would change to a positive. There was a 5 here, so make sure you're not forgetting that, and then bring down everything else. You could combine like terms, this 5, this 6, on the same side. Remember, we can only combine like terms if they're on the same side. So that 5 plus 6 would give us 11. No, minus. Right, and then at this step, you can pick whatever you want to move. And you can either move them both at the same time or move them separately. It doesn't matter. So let's say we did this at the same time. I'm going to move the -5/2 over by adding. And then because I moved the x's to the left, I have to move the constants back to the right, adding 7. And again, if this is not exactly how you did it, at this step you have choices, so it's okay. As long as we get that same answer after that, you're good. So I can do this in the calculator. You could also do it by hand, but I'll show you how to do it in the calculator. So grab your fraction, alpha y equals, hit 1 or hit enter, type in 1/2, come out of the fraction, hit plus, and then you're going to do it again. Alpha y equals, grab your fraction, and then 5/2, or 5 over 2. So what it did was added the numerators, because we have the common denominator, which would have gave us 6, and 6 divided by 2 was 30. And add a 6. So we would have had 3x on the left and 18 on the right, and then divide both sides by 3. So you get 6 as our final answer. Try to get in the habit of showing all of your steps, especially when we get towards the quiz, the test. I don't assume anything, even if I know what the actual answer is, so I need you to walk me through your process as if I have no idea what's happening, okay? So I need to see every single thing. How did you get from here to here? Every single step. Okay? Questions on that one? Okay. And then number 3, Andre solved this equation. What does Andre's work show us about the type of solution to the equation? What did we get there? What did we say? Erica?
I said no.
Okay, why?
I said no solution because 2 is not equal to 0.
Correct. So because of that last line, 2 doesn't equal 0. That's part of it. Because the 2 doesn't equal 0, we know that's not a true statement. But also because the variables disappeared, that's the second part. So your variables have to disappear, and you have to get an untrue, not true statement or equation. Did you have any questions about that? Okay. Before we jump into our new stuff for today, I just wanted to recap, refresh if we had any questions about anything we did last class. So some of you started the Delta Math that's due tomorrow on that. If you we're stuck on a problem, I can pull that up and we can go through it. Was anyone stuck on like a delta math problem that we want to see? Do you remember what was in it? I can pull up what you. So you don't need your delta math, but you can write this on a piece of paper. Like if you get this problem, it may help you. Back. Come here. I just want to make sure this is the right one.
So whatever one I got one.
Okay, so yeah, this one.
Yeah.
Yeah, okay. Let's do this. I'm going to pull this over here, but I'm also going to do this. Did that pop up yet? Okay. So the problem was, let's see if I can put this x plus 9 equals 7. So somewhere where you have blank space, write this problem down. Or if you want to get a piece of paper, or if you want to write it on the desk, somewhere write it down. This was Becca's specific problem. You may not get this exact one, but you may get one similar. Okay, so when we have a fraction that equals another fraction, what's our first step? Cross multiply. So I'm going to take everything here, multiply it to this. I don't know if I can change the color up here. This thing's weird. Anyway. And then same thing here. The 7 to everything up here. Yes. Some 30 after they got. Great. And then it doesn't matter which part I put first. I'm going to start with the 6 just because I could have started with the 7. And then use parentheses, x plus 9 equals my 7, and then in parentheses 5x minus 8. So I'm cross multiplying this to everything here and this to everything here. And then I want to go ahead and distribute the 6 to everything inside, the 7 to everything inside. You can use your calculator. I'm going to do some mental math up here. So 6x plus 54 equals 35x minus 56. And then we have some choices. We can move whatever we want. I would like to keep these as positive as possible. So I'm going to move 56 over. You don't have to do it that way, but that is one way to start it. And at the same time, I'm going to go ahead and subtract 6. Make sure you have that x with it. So 54 plus 56 would give us what?
Between 50.
I heard 110. Thank you. I'm going to write this over here. I'm running out of space. And then 35 minus 6 should be 29. And then our last step would be to divide. 29 is not going to go into this evenly, so we would leave that as a fraction. So all of those type of problems you're going to set up the same way, start to do the same things. Remember, you can use Desmos To check yourself if you need it for like basic calculator things too, that's also fine because you don't have these calculators at home. Yes. So here, since whatever number is next to x, that's whatever I'm dividing by, and then that does the same. Other questions on that? If you have those notes from last class, were there any other questions we wanted to go through, either on the infinitely many no solution page or on the page where we're doing a bunch of problems together? Either of those. Do we have any last minute questions before we start our new notes? If, while I get the notes, you remember something that I do want to go over this, just let me know. I don't know if I hit play on that. Alright, so today we're going to be talking about literal equations and what that means and how we solve them in XYZ. But first, what's the difference between these two sentences? It's raining cats and dogs, and it's literally raining cats and dogs. What do you mean it's actually happening? Like like you can see cats and dogs falling from the sky. It's actually happening. That one is literally raining cats and dogs. It's actually happening. This one is more of a saying. Yes, saying. It's raining so hard it could be as if cats and dogs are falling from the sky. So then when we look at, well, these are just some more literal examples. When you say I got your back, you're not literally meaning this, because that would be scary. Just so that we're all clear on what literal means, actually or without exaggeration. But a literal equation is where we have some math equation, and we're going to actually solve it. However, we're not going to get an actual answer. So we're just actually solving it as if there were numbers, but there are letters and variables instead. So that makes it seem like a little daunting, but once we get in the habit of actually solving it, we'll see it's not that bad. So like in this case, let's say I were to solve this for x, I'd want to get rid of the y, and I don't know what either of those mean. I could pick a bunch of different sets of numbers and put them in, and any of those numbers would make it true. But I just kind of want to get one of the variables by itself, whatever that means. Go on to this page. So think of the same sort of rules that you would use just to solve equations. Use your order of operations if you need them. Usually there's not a whole lot of distributing, but if that happens, do that. Think about how you would get rid of fractions, how you get rid of whatever's next to the variable, things like that. They are... Alright, so we're going to do like a mixture. We're going to do some actual equations, and then we're going to do some literal equations and see how they're the same or different. Okay, so for example 1, how would I solve this? How would I get that x by itself? Divide both sides by 2. So that x is 5. Good. Now, in example 2, the format is similar, but we don't have any numbers. We want to solve this problem for h. We want to get h by itself. How could we get rid of g? Divide g. The same thing we did here, we're going to do here. So we're going to divide both sides by g. It's really confusing because they're just letters, like what are we even doing right now? Imagine this problem was this. Where x is, h is now. And we're doing the same process. Now, when we divide both sides by g, this still cancels like it would here. However, These are not numbers, so we can't do anything with them. We can't combine them. It just becomes m over g. We rewrote it, basically. This would be our answer. H equals m over g. I have no idea what any of that means, but I know that if I had numbers to put in, I could figure out what h is by dividing m and g by those numbers. It's once we get the hang of it, it may make a little bit more sense. It still may not. Literal equations is confusing regardless. What questions do we have right now, though? Let's try example 3. How would we solve this? Get x by itself. Divide by what? So we will divide by 2, but not first. We got to get rid of that 5 first. Yes. So when we do that, we get 2x equals 6. And now this is just like example 1, and we can, what Rocky said, divide. So that x is 3. Okay. And then example 4 is set up just like example 3. We are also solving for x, but there aren't any numbers. What would we do first? So not divide.
No. Subtract b.
Subtract b,
B
okay.
over c.
So we're going to subtract b to both sides. The b is going to cancel. But c minus b, I can't do anything with that. I'm just going to rewrite it. Just like that. No, that's not our answer yet, because we haven't gotten x by itself. How would we get x by itself here? Divide by a. Get rid of the a on both sides. So the a cancels here. And then I have this weird equation over here that's what x equals. C minus b all over a. Period. Done.
What are we going to use this for? Like in this class?
In this class, it's going to help us graph later, yes. So there is a purpose. But in the real world, not a whole lot unless you're like doing engineering stuff. Right. Other questions? Alright, now this one has variables and numbers, but we're still solving for just one variable. If I were doing example number 5 and we want to get x by itself, what do we think we would do first? So we would get rid of the 3, but not first. We would say that again. Plus 6y. Yeah, we're going to get rid of that whole term. So we don't want to separate it because that wouldn't really help us do anything. But this entire term has nothing to do with x, so we can get rid of the whole thing by moving it over. I'm going to rewrite it first. And then I'm going to take this whole term and just add it to the other side. Yes. You are second in line. So then here, these 6y's cancel. I do have my 3x. And then I cannot combine these. They're not like terms. One has a y, one doesn't, so I'm just going to rewrite it. So we're actually going to do this a little separately. So if I could not divide either of these, so what Nathan was saying, if I were to divide these both separately, I would get a decimal, a fraction here. That is true. We're still going to do it, but we're not going to make it a decimal. It's just going to stay a fraction. Because I can divide this by 3, and it'll simplify. So anytime it can simplify, you want to do that. Allison, go. So divide each thing by 3. So we get x equals, this won't be a nice number, leave it as a fraction. And then this we can simplify. questions on that one? That is it. That is our final answer. So we got x by itself. That was our whole goal. If I had a number for y, I could solve this a little bit more and actually figure out what is x's value, but I don't know that information. Sure. Let's jump to the letters and then I'm going to have you guys. These are very similar, so I'll let you guys pick 7 or 8. Okay? So think about the same things we just did here, because it's set up very similarly. We just now have different variables. We're trying to get c by itself. What would be our first step? Yes. By doing what? Because it was adding to it, so we're going to subtract AB on both sides. So that we get CD equals, we can't combine these, so just G minus AB. And then our last step, how do we get C by itself?
Divide.
Yes. Now in this case, unlike here, I don't have any D's in the problem, so I can't divide it separately. So this is just going to be, oh, I crossed up the word here. C equals G minus AB all over B. And that is the final answer. What questions do we have about any of that? Something we gotta talk about. Right. I want you to try example 8. And then we'll come back in a couple minutes and talk about that, and then move on to some of the harder examples, and then you'll have time to practice. Alright, let us come back. Do we want to go through this one, or someone tell me the answer, and then we can see if we got it right? Go through it, okay. And then when we get to the end, we'll see who all got that same answer. So what should we have done first?
Subtracted CD.
Yes. On both sides, so we get AB equals G minus CD, and then divide both sides by B. Because we're trying to get A by itself.
Oh.
So our final answer should have been A equals G minus CD all over B. How many of us got that? Okay, good. If you didn't get that, it's okay. We are practicing in the mix. Julia's next, and then Evan can go. Go on to the next page. So just like last class, I want you to pick any of those problems that you're not sure. How would we start that? And we'll go through those together.
3, 2, 4.
3 and 2 and 4.
Yeah, 6 is confusing.
Okay, we will do all 4.
6 and 3. No, 6 is
Are you done with that page? Yeah.
Yeah, no,
2, 4, 3, and we'll do 6. Alright. Because 3 is actually a little weird, and you might see some of these type of problems on Delta Math, so this will help you. So we want to solve this for t. I was thinking of something else, but I can find a problem somewhere. Okay. I'm going to solve this for t. So just like we were just doing, we want to get rid of anything that we're adding and subtracting first. So we can get rid of this p by doing what? Subtract p on both sides.
Did you subtract 2p?
So no. Only because this one is connected to something else. So these are not like terms. If they both had that PRT, then yes, I could do something more with that. Okay. And then If this were just like R and T, I would just divide it. But because it has P and R, I'm still dividing, but I can do that all at the same time. I can divide both P and R at the same time. So that our final equation would be A minus P over PR equals T.
This don't make sense. Okay.
Did you have questions about that one or get lost?
It's just all the letters.
Yeah. So I would say if it helps, circle or underline what you're supposed to be solving for first. That way you don't get lost in all the letters. And then just focus on pretend, okay, everything else is a number. How would I solve this if it were a regular equation? And then that might help.
Well, but then we can't actually solve
But yes,
it.
but don't actually solve it for a number. That's the confusing part of it.
This is great.
Alright. In number 3, we need to solve for f, which is inside the parentheses. Which means we gotta get rid of this 5/9 before we do anything else. We can do one of two things. Either distribute that, and then we'll have to do something back with it, or get rid of the 5/9 completely. Which one would you rather? Distribute or get rid of? Get rid of. Get rid of. Okay. So think back to when we were solving with some of our fractions, and we flipped it and multiplied it. We're going to do that same thing here. Take this and flip it and multiply it on both sides. Flip the fraction. Yeah. It's called the reciprocal, flipping the fraction, flipping
Yeah, this
to
is
it.
like you're
Yep.
9/5.
That's what the answer will be on that side, yes. So when we multiply these two, if you check this in your calculator, you get 1. These cancel. So we have 9/5 C. Because there's nothing there anymore, we can drop the parentheses. So that we have F minus 32. And then to get F by itself, what would we do?
Get rid of
32.
By doing what?
Try. Add.
Now, these are not like terms, so we're just going to rewrite it. 9/5 C plus 32 equals F. This is a real formula in real life. You can use this in real life. If you were ever curious about Celsius to Fahrenheit, that is that conversion. I don't know. I don't recall who created literal equations, but I could look that up for you if you're curious. Okay. Any other questions on that one?
So that's the final answer.
That is the final answer.
How do you know when it's the final answer?
When whatever you were trying to solve for, so here we were trying to solve for f, is by itself. Good questions. Alright, number 4, solving for m. If we're trying to get m by itself, how can we get rid of v? Multiply. That was it. Some are harder than others. It just depends on what we're solving for. If we had been solving for v instead of m, there would have been a little bit more steps to it.
Maybe you should put one of those in here.
We could do the same problem, just change it. Would you like to do that?
Is it going to be on any tests like that?
Possibly.
Yeah.
So somewhere where you have space, we'll do the same problem, but now we're going to solve for v instead of m. Multiply what? So if we were to multiply by m, that is just going to make m squared, and I have to add m on both sides. V would still be in the denominator, so that doesn't really help. In this case, we actually have to move the b, and then we're going to have to do something else with it. By multiplying, because that's the only way to get it out of the denominator. Think about it, we're dividing b, so to undo that, we have to multiply. We are multiplying, but by b, so that these cancel. Still have b on this side, but then how would I get b by itself? Divide by b. If you remember, something you could have also done. Evan, go ahead. This is a fraction, yes. I want to say that I mentioned that all of your whole numbers are really fractions over 1. All of your letters are also the same thing. So then I could look at this as a fraction equals a fraction. And when we have something like that, what would we do? A fraction equals a fraction. How do we solve those? We did that here. Cross multiply. And then we'd be back at the set and we'd be doing the same thing. I put DB instead of VD. That order doesn't matter.
Okay.
Sorry.
Very confused. Can I do the bathroom line?
Yeah. So I would say I forgot who was next after Miriam. Who's after Evan? I think it was just Rocky. I don't recall anyone else, so Rocky and then Eric. Okay. Alright, and then 6. It's going to be very similar to number 4, 5, 3, whatever this number was. 3, thank you. Okay. Alright, B1 is on the inside. We have to get it out of those parentheses. So let's get rid of the 1/2 the same way we got rid of the 5/9. Flip it, multiply it. So that the numbers on the right cancel. Now, it's still in parentheses because you still have that h, so don't get rid of those yet. This was 2 over 1, but it's the same thing as just 2. Now, I want to get rid of that h. Very similar to one of the options I said here. We can distribute it, or we can, in this case, divide it. Which would we rather? Okay. We're going to have 2a equals hb1 plus hb2. And we have to get another page because somebody else is. We can get rid of the hb2 completely because we don't need that. That's subtracting. I'm just going to write this over here. Now we're still trying to get B1 by itself. How would we get rid of H? Divide by 8, but because we distributed it, this is the issue sometimes with this. Because I distributed it, it's everywhere, so now I have to divide it separately because this is going to simplify. So that this h cancels and this h cancels, and I have 2a over h minus b2 equals b2. We would have got a similar answer if we had just divided as well. Okay. I want to give you time to practice. So, for up until about class ends, 12:17-ish. You guys can choose one of these three things. If you finish one, start something else. Keep working in these notes. We'll be around. We can answer any questions you have. You have a Delta Math on this also that is due tomorrow. You have 2 that are due tomorrow. This and the one from last class. Be working on those. Or you could do the discussion on literal equations that is due today. Okay, so pick one of those things, do that. If you need an iPad, grab it. You can do it on your computer. Or keep working in that. If you need help, raise your hand, we'll be around.
What's